Okay, we're gonna take a look at the latest research on music, um, neuroscience, and how music training changes the brain. And this is very fascinating because it corroborates my own experience in intensive music training from a young age. And basically, the concept is called metaplasticity, which means essentially that you are, by music training, you are significantly increasing the gray matter neurons in the cerebellum, which has the largest proportion of neurons in the brain compared to the rest of the brain. So they did a study here and they're showing a significant increase in gray matter in the cerebellum of musicians versus non-musicians. So that's sort of the basic message here, but there's some very intriguing details that connect it into meditation and the same connection that I experienced from my own training. So it's nice to have science corroborate my experiences from over 30 years ago, 35 to 40 years ago. And okay, so we have this larger volume of gray matter, which is again the neurons of the cerebellum. But we also have just a larger activation of the brains by musicians when you're listening to melodies. And I notice this when I listen to music, that my brain gets much better stimulated than because of my music training. And that stimulation covers more areas of the brain. So the gray matter of the cerebellum houses the neurons crucial for processing motor signals, but also for processing emotions. And of course, in meditation, that connects us to the vagus nerve, which is closely tied to the listening process through music, and the pineal gland is the third eye. And so the gray matter has the highest concentration of neuronal cell bodies, but the cerebellum has the greatest concentration of neurons compared to the rest of the brain. So what we find is that rhythm and timing is left cerebellum dominant, while pitch, frequency, and melody are right cerebellum dominant. But because of this brain integration, it gets a bit more complex, but that's on the basic level, that's true. And as I said, especially from early music training, they've documented a significantly larger corpus callosum that integrates the right and left brain from early music training. But that metaplasticity occurs throughout all of life when you do music training. And so the increased gray matter is neurons. There's also a decrease in the white matter. And so essentially that's showing a more sophisticated use of the neurons as more efficient, or whatever word you want to use, better filtering skills of the cerebellum, as signifying the metaplasticity of the brain. And that coordinates the emotions and the movement along with cognition. And so this musical rhythmic training has been proven to heal conditions like strokes, Parkinson's, dementia, and what psychiatrists call the autism spectrum disorder. Or this is kind of subjective how it's defined, but essentially, they're showing that when you have a larger gray matter and smaller white matter, that's actually the opposite of what is symptomatic of ASD and all these other conditions as well. And what's fascinating to me is perfect pitch is actually left brain dominant, with musicians showing a stronger left brain processing compared to non-musicians having right brain dominance for melody and pitch and all that. So again, this is what I meant by the more complicated processing, because you're having this overall brain integration. So even though frequency is right brain dominant, it's also right cerebellum dominant, but the right cerebellum is actually connected to the left brain, the left cerebrum. So when you have this more sophisticated left cerebrum dominance by musicians for processing pitch, you also have a deeper right cerebellum dominance for pitch frequency dominance, and vice versa when you have a deeper rhythm timing left brain dominance in the cerebellum, then you have a stronger right brain dominance of the cerebrum. And of course, this eventually opens up the third eye. So the right hand movements on an instrument for pitch perception then also exhibit stronger beta brain wave suppression. Again, this is due to that right brain dominance for frequency, and greater training of mu waves as alpha brain waves for sensory motor processing. So this is something I experienced personally when I took part in a paid medical study at the University of Wisconsin-Madison, and the nurse had to give me an EEG to prepare me for the study, and I had no idea. I had never taken an EEG before, and she exclaimed out in great surprise, "Wow, you have really strong alpha waves." So it turns out that I had immediately realized, well, this had to be due to my music training, because I knew that I experienced this great sense of joy from my music training. Like my heart felt really open and with lots of love, and I felt really relaxed from my music training, especially this the second movement of the Bach Italian Concerto in F major. The second movement had a 1 beat per second, which is this with the heartbeat, so that would cause this deep relaxation and slow down the brain waves. And so the basic timing of rhythm, when you have that basic left hand rhythm that keeps a steady beat, that is found to be, even in babies, as pre-attention. And so this is something we're evolved to have as humans, is to have this synchronization with the beat, and also with music. So of course this varies based on how much a culture emphasizes the music training. So what they found is that well, I'll get into this more later. I cite the details more as we go along. Oh, so what they found is that when you have this mu synchronization, which is the alpha brainwaves for sensory motor processing, so they call it mu brainwaves. It also happens when you're not listening to music, but to discrete sounds like words. So, in other words, that sense of strong alpha brainwave keeps occurring even when you're not listening to music due to this music training. So that's what the nurse discovered about my brain before I had done any meditation. It was when I was still undergraduate. Left brain's cerebellum has reciprocal projection with the right cortex. Yeah, this is what I already mentioned. And so again, you have this right cerebellum for pitch processing, but you have the left cerebellum also for the right cortex for music processing. So you have the left cerebellum for rhythm and timing, but it activates the right side of the brain for frequency processing. So you get this overall brain integration. So again, this was found even with twins. This study, no activation was found in amusic subjects in the cerebellum. So again, you're getting this much greater cerebellum activation from the music. And so you have the right side cerebellum for frequency or tone as pitch. So this is just the study results, and I'm citing early trained musicians had reduced white matter in the cerebellum, but it's increased gray matter, as I already showed, for neurons. So you're getting a significant change in your brain from the music training, which is really fascinating. I mean, I had no idea when I started training in music that this was what was happening. Musical training induces morphological changes in the cerebellum independently from the type of musical performance. So again, the left cerebellum is the key for beat, interval discrimination, rhythm discrimination. So here we have a twin that studied in music and then a twin that did not study in music at all. And you show that the musically active twin had greater cortical thickness in the left hemisphere and more developed white matter. So you're gonna get, let's see, the volume of gray matter in the left cerebellum was larger for the music playing groups of twins. Okay, so they're groups. Music compared music had a significant increased activation in the left cerebellum. So again, it's just proving that the music is a key factor in brain development. So they're showing that this occurs throughout your age, through your whole life. The music training is key. So again, this is why music therapy is so effective for treating all sorts of conditions, neuropsychiatric conditions, and neurological conditions like dementia, stroke, Parkinson's, and autism spectrum disorder. Reported benefits of music training are highly dependent on the age when the training begins. So that just proves that if you start at an early age, you're going to get the better results. Basically, it gets hardwired, but if you do lifelong engagement, then you can maintain the benefits even into old age. But early training has been associated with decreased white matter volumes again. Significantly reduced white matter volumes. Extensive musical training was associated with reduced volume in the cerebellum, in the white matter. These findings are suggestive of a reduced activation due to expertise, which has been noticed in the cortical regions of musicians and dancers in previous studies. This could be attributed to the concept of metaplasticity that allows more sophisticated processing of musical notes and filters out irrelevant sensory inputs, thereby using lesser brain volumes. Metaplasticity refers to the long-term neural changes that occur due to repeated exposure to an activity over a significant amount of time, and it often acts as a scaffold for further development. It is important to appreciate the morphological changes induced by music in specific brain regions like the cerebellum. It is interesting to note that cerebral size is larger in neuropsychiatric disorders, like autism spectrum disorder. So this is interesting because, if you get deep into meditation, then people might think you have some kind of neuropsychiatric disorder, but it's actually it's the exact opposite. It's like a projection of people not realizing that there's this deep brain transformation from music training that then leads into meditation. We observed a significant increase in cerebral blood flow volume in the right hemisphere in non-musicians during harmony perception, but not during rhythm perception. This effect is more pronounced in females. Language perception was lateralized to the left hemisphere. So again, you have this right brain for harmony perception or pitch or melody, right brain dominance. The time to reach the peak of cerebral or blood flow is significantly larger in non-musicians compared with musicians. Pulse rates were significantly decreased in non-musicians during harmony perception, probably due to a specific relaxation effect. So this is again where you're getting that suppression of the beta brain waves, and then the alpha brain waves are taking over. Okay. Okay, so musical ability is associated with enhanced auditory and visual cognitive processing. Okay. So, basically, for instrumentalists, here's what I was getting into before. For instrumentalists who have experienced associating right hand movements with pitch perception and music performance. They may represent a more efficient use of cortical resources. So the mu waves are for alpha brain waves for motor processing. Taking in light of previous finding, enhanced mu and suppressed beta may indicate greater cortical demands in response to sounds associated with the motor action. So this is exactly what the nurse found out about my brain. She was like, "Wow, you have really strong alpha brain waves," and I realized it had to have been because of my music training. And so this study corroborates what I experienced on an individual level. Okay. The right sensory motor cortex, contralateral to piano-trained hand, exhibited greater beta suppression in musically experienced subjects. Okay. So that's contralateral. So that's the left hand. See, I'm left hand dominant. This might explain, in part, previous reports indicating a preferential role of the right hemisphere in relative pitch processing. Oh, they mean the... Okay, right sensory. Oh, that's the cerebellum. The sensory motor cortex. It's got to be tied to the cerebellum. Let me see if it is. Well, let's just look at the... Is this the same study? Yeah. Anita. Let's see if they cite the cerebellum. I don't think it's... I have to like download it or something. No, it's... Sense. Okay, sensory. Okay. The central... Okay, the central sulcus. Alright. Okay, well, it's not quite the same as the cerebellum, but it gets the point across. So, increase. Oops. So when they're saying when you learn the song by memory, then you get this increased effect of beta wave suppression. So that was my whole point, is I had to memorize the Bach Italian Concerto in F major with the slow movement, and I realized when I had memorized it, it was that process of memorization that caused this transformation of my physiology. And so yeah, that's the key point, is they're saying when you memorize it. So memory. Oops. I don't think they say learn, they just say learn. Learn to play by ear. That's what they say, learn to play by ear. So that's the same as memorize. Okay. I was just talking about this the other day. Oh, suppression. Increase no suppression for the control cell. Yeah, so they're saying if you learn it by ear, it's going to attenuate the beta wave suppression. That's what they found. Beta and gamma were generally suppressed relative to baseline. Theta and alpha brainwaves revealed consistent enhancement of power. And that's really fascinating because the theta is like a waking REM state. Okay. Beta suppression at electrodes. So when you learn it by ear, you have a significant difference in beta suppression right there. Fascinating. Look at that beta suppression when you learn it. Learning it is this light green, the light green bar. There you go. That's all we need to. That's proves. This proves what I hypothesized, my own experience.